We're always told to trust the numbers, but what if the numbers can actually be nudged to tell different stories? Today, we're going to dive into a study where one simple choice, which statistical test to use, completely flips the entire conclusion. Let's see how it works. That is a fantastic question, right? Because as we're about to see, raw data doesn't just speak for itself. The real story is often buried, and picking the right analytical tool is like having the right key. One key can unlock the truth, while another, well, it might open the wrong door entirely. So here's our game plan. First, we'll talk about why choosing the right tool is so important. Then, we'll get into a really interesting correlation puzzle. We'll see what happens when your data doesn't follow a straight line, look at a different kind of comparison, and finally, we'll pull back the curtain on what the numbers really had to say. All right, let's jump in. Section 1, choosing the right tool. The big idea here is simple. Think of statistical tests like tools in a toolbox. I mean, you wouldn't use a hammer to saw a piece of wood, right? The exact same logic applies to data. Think about it. Every single data set has a story buried inside it. But here's the thing. Picking a statistical test isn't just some technical, boring step. It's about figuring out the language the data is speaking before you try to read it. Now, to really get what happened in this study, we got to talk about something called scale data. It's actually pretty simple. Just picture a ruler. The distance between 1 and 2 inches is exactly the same as the distance between 10 and 11 inches. The steps are consistent, they're meaningful. This is going to be super important. And bam, right out of the gate, the researchers hit a wall. One of their key variables, something about smoking, it just wasn't scale data. Maybe it was in categories like non-smoker, light smoker, heavy smoker. Whatever it was, it immediately raised a huge red flag for the test they were planning to use. This quote from the analysis just says it all. The Pearson test, which is one of the most common tools out there, demands that ruler-like precision we just talked about. So when you try to feed it data that doesn't have that kind of precision, well, the test can give you a really wonky or even a completely misleading result. So this brings us right to the heart of the puzzle. Pearson versus Spearman. The researchers knew their first tool wasn't quite right for the job, so they brought in another one to see what would happen. Let's meet the contenders. First up, we've got Pearson's correlation. You can think of it as the traditional workhorse of statistics. Its job is super specific. It is looking for a perfect straight-line relationship. As one thing goes up, does the other thing go up or down in a perfectly consistent line? But then you have Spearman's correlation, and it plays a totally different game. It couldn't care less about the precise values. Instead, it just converts everything into ranks. First place, second place, third place. And then it just checks if those ranks turn to move in the same direction. Okay, this table breaks down the crucial differences. Pearson needs that perfectly straight line, while Spearman is cool with just a general trend. But check out that last row, outlier sensitivity. This is absolutely huge. Imagine one person in the study had a really extreme, weird sleep pattern. That single data point could totally trick the Pearson test, but Spearman, because it's using ranks, would barely even notice it. And that is how these two tests can end up telling completely different stories from the exact same data. So, Section 3, when data isn't linear. What actually happens when you unleash both of these tests on the same set of data? Well, as you might guess, the results can be like night and day. So if you get two wildly different answers from these tests, don't panic. It's not a mistake. It's a massive clue. It's your data telling you that either the real relationship isn't a simple straight line, or that a few extreme data points, those outliers, are dragging the Pearson result completely off course. Now, in this study, the alarm bells went off big time when they looked at a variable they just called answer Q3. We don't need to know what the question was. All we need to know is that for this one piece of data, the choice of tool made a massive difference. And boom, here is the evidence. Don't worry about the exact numbers. Just look at the gap between the Pearson score and the Spearman score. A difference this wide is basically your data waving a giant flashing neon sign, screaming that a simple straight line analysis is absolutely missing the real story here. Okay, so finding relationships is one piece of the puzzle. But the researchers had another question, and this one needed a totally different tool from the toolbox. They wanted to compare the sleep quality between two different groups, men and women. And for this job, they brought in the Mann-Whitney U-test. Its goal is pretty straightforward. It just wants to see if one group generally has higher scores than the other. And just like Spearman, it's really flexible. It doesn't assume your data fits that perfect bell curve shape, which is great because let's be honest, real-world data almost never does. And guess what? Using the right tool for the job paid off. The analysis showed a statistically significant difference in how men and women in a study reported their sleep quality. In other words, the difference they were seeing was almost certainly a real thing, not just some random fluke in the data. So we know there's a difference, but what does that actually look like? The test gives us the median, that's the middle value for each group. So any guesses what it was for the men in the study? There it is, 138.42. You can think of this number as the group's center of gravity. It tells us that half the men in the study reported sleep quality above this number, and the other half fell below it. By comparing this to the women's median, the researchers could really nail down the direction and the size of the difference they'd found. All right, Section 5, what the numbers revealed. We've talked a lot about the how, the methods, the tools. Now let's get to the what. After all that, what did the researchers actually find out about sleep? Let's check out the insights. Okay, here's the first huge finding. A staggering 88% of the people in the study said they slept longer on weeknights. This wasn't some subtle little trend. This was a massive, dominant pattern in the data. This is the kind of clear, simple statistic you look for before you even think about running more complicated tests. But here's where it gets really cool. The story isn't just about that big majority. The analysis also found a fascinating little subgroup. 101 people who reported getting the exact same amount of sleep on weeknights and on weekends. It's a great reminder that even inside a powerful trend, there are always these distinct groups with different behaviors. Data is never just one single story. So let's pull all this together. What's the big lesson here? Well, first, always check if your data actually fits the assumptions of the test you're using. Second, remember that how you choose to look for correlation can totally change the story. And finally, by using the right tools, this study found real, measurable differences in sleep patterns and a super clear trend in how long people sleep. In the end, what this whole thing really shows us is that statistics isn't some magic black box that just spits out the truth. It's about using the right keys to unlock all the different stories that are hiding just underneath the surface of the numbers. It really makes you wonder, what important story is just waiting to be discovered in the data that's all around you?